Hello! Today's topic is solving rational inequalities. Now, you'll see some similarities back to when we were solving rational equations, and there's also a bit of similarities to back when we were doing inequalities in Unit 5 with radical equations. Okay, so feedback I've been getting is that we really like when we have steps to follow. So what I've done over here off to the side is I have my little table with all the steps that we're going to go through today. If you want to pause the video now and copy those down for your reference, please do so. All right, so our first step is a sort of gimme because as you've seen with the previous lessons, our first step with these rational functions is usually to factor, and here it is again. So in this case, on problem number 1, we are all factored, so we're good. Go on to step number 2. Now, this is where we see a similarity to solving rational equations because we want to find the least common denominator. I'm going to be abbreviating that with LCD. Now, in this case, our least common denominator is just x plus 5. How do I know that? Well, with least common denominator, I want one of each denominator being multiplied together, and this 4 could have been written over 1, and 1 times anything won't make a difference, so that's why I just have x plus 5. The second part is to use this to find where the function is undefined. Remember, we have an issue where our fraction has a denominator equal to 0. So what we're going to do is set our least common denominator equal to 0 and solve. Here this gives us that we are undefined at x equals -5. I'm going to circle this number because this is going to be one of our critical points. So this is one place where we can find our critical points. You'll notice that that vocabulary comes up in step number 4. For now, just circle it and make note of it. We'll talk more in detail about what this means in step number 4. The second place that we can get critical points from is from solving. Now here, since we're just interested in the point, then it's okay to rewrite your inequality as an equation. That way we can solve it just like we did before when we were working with rational equations. All right, so how do we solve these equations? Well, we would multiply every term by our least common denominator. That's what I'm going to do here. 8 times x plus 5. X plus 5 is in the bottom. 4, I'm going to multiply that term by our least common denominator as well. The reason we did this, as you can see over here, is because it allows us to cancel out our denominators and our equation looks much nicer. I can divide 4 from both sides in this case, leaving me 2 equals x plus 5, so that x equals -3. Now, like I said, what we care about here is the number, because that's going to be another critical point. So in summary, the critical points that we're talking about in our next step come from where our function is undefined and also to the solution when we set this equal and have a rational equation. Take some time now to pause the video and make yourself a note in your own words so that you can remember what your critical points are. Okay, so step 4 is to plot these points on a number line. Here's where you might see some similarities to when we were working with inequalities, since number lines came up at that point as well. Now we want to plot them the way that we would see these on an ordinary number line. So -5 is less than -3, therefore I'm going to put it on the left. Now this breaks up our domain, because we are working with our x's, into 3 regions, or sections. Namely from -infinity to -5, -5 to -3, and -3 to infinity. Now, in order to see where our solutions are, or in other words, where this inequality is true, we want to see what's going on at each of these regions. We can do this by doing some test points. What that means is I'm going to choose an x value somewhere in this region, and plug it back into my inequality, see if it's true, and so on and so forth with the remaining regions. Let's do that now. The points that I would like to use are -6, -4 in this section, And in this section, I'm going to choose -2. Notice that you could have used any x value as long as it's within this region and not including our critical points. All right, so when I plug in, let's look at this section first. My x equals -6. I find that I have 8 over -1 is less than or equal to 4, which means -8 rather, is less than or equal to 4. Now, is that true? Yes, it is. So in this region, our inequality works. I'm going to make myself a little note about that by putting a T and circling it there. If you'd like to make your notes differently, please feel free. Now I'm going to go over to my next test point and see what's going on in that region. 8 over -4 plus 5, well, that's just 1, and that'll be less than or equal to 4. Is 8 less than or equal to 4? Nope, doesn't work. So at this region, our inequality is false, does not work. Lastly, when we plug in x equals -2, we get 8 over 3 is less than or equal to 4. Multiplying both sides by 3, that's really saying that 8 is less than or equal to 12. Is that true? Yes, it is. All right, so we've done our test points and we figured out in which regions our inequality works. Our final step is to write our answer, and here's where we're going to consider whether to include our critical points in those regions or not. Okay, so first thing, I'm going to start from left and move right, so -infinity to -5. That region worked, so I'm going to have -infinity, -5. Now I want to figure out whether I'm going to do an open parentheses or a closed bracket. Either to not include the point or to include it. Now -infinity, we can't include that, so it's going to be an open parentheses. -5. Now here's where I go back and look, what did this pertain to? This was where my function's undefined, so I can't include it because my function doesn't exist at that point. The interval from -5 to -3, that didn't work, so I don't need to write it down in my solution. What I do need to consider, though, is from -3 to infinity. That was another place where our inequality was true. So -3 and infinity. Now infinity, same way that I couldn't include -infinity, can't include it here, so I have an open parentheses. -3, though, came from my solution. Here's where I do go back and look at what my inequality was doing. This was less than or equal to, and so I can include this point because of that equal there. I do include it, so I'm going to have a closed bracket. That means that our inequality is true if our x is in this interval or in this interval. How do you know that this is or and not and? Well, think about it. Can you have an x that's both in this interval from -infinity to -5 and this interval? No, it just needs to be in one or the other and the inequality will be true. So that's our answer. Notice that I could have also written this instead of an or, could have written it symbolically with my U symbol, meaning to unite or the union of these two intervals. Wait, did you remember that? Okay, either way is correct. And you could have also written these differently, different notation, saying -infinity is less than x is less than -5, and so on and so forth for this interval. That's okay too. For our next example, we're going to try to pick up the pace, but as long as you're following these steps, you won't get lost. For number 2, if you'd like to go ahead and try it on your own and then double check your answers, that's okay with me. Just come back and watch the video for sure for number 3 and number 4, because I have some particular notes to make about those. All right, ready, set, go. Number 2, step 1 is to factor, but we're all factored out, so we can go on to step 2, finding the least common denominator. That means I want 1 from each denominator. That gives me an x and also an x minus 6. I've considered everything. That's my least common denominator. I want to use this to find where the function is undefined. So that's when this whole thing's equal to 0, or where these individually are equal to 0. That gives me that we're undefined when x equals 0 and when x equals 6. I'm going to circle those because those are going to be some of my critical points. Next thing I want to do is to solve if I consider this as an equation. That's 6. Multiplying both of these by my least common denominator, which I'm going to write in red, x minus 6, allows me to cancel out my denominators. So I have x minus 6 times x minus 2. I'm going to go ahead and distribute this out. I'm going to get x squared minus 8x plus 12 equals, that left me with an x times an x minus 4. Distributing that, I get x squared minus 4x. I have an x squared on both sides. Subtracting them, they cancel out. I can now move my x's over to the same side. I'm going to choose to add the 8x to both sides, leaving me with 4x on the right-hand side. Dividing by 4, I get that x equals 3. This is my last critical point. Step 4 is to plot these on a number line in numerical order. So 0 is the smallest, followed by 3, and finally 6. I want to now look at test points. The test points that I'm going to consider in this case is -1 for this section, 2 for the section between 0 and 3, 4 for the section between 3 and 6, and finally 7 for everything bigger than 6. Remember that you can use any number that you would like within these intervals as long as you're not considering those critical points. Now, what I find to be the most time-consuming part out of this whole process is actually plugging these test points in and figuring out whether the inequality holds true or not. So what I'm going to do, you don't need to see me plugging in x values. I'm just going to put up my work now so you can see where I'm getting my numbers. And then we'll come back and talk about where it worked and where it didn't, right? And magic. Okay, so go ahead and compare your work for plugging these into the equalities and see what you got. What I saw was that from -infinity to 0, that did not work. It did work from 0 to 3 because my test point 2 worked. When I plugged in 4, I got something that wasn't true. And when I plugged in 7, I got something that was true. Now let's write our answer. So I know I'm going to be working with the interval from 0 to 3 and the interval from 6 to infinity. At 0, that's where I'm undefined, so I don't include it. At 3, I go to my solutions, and so that means that I'm looking at my inequality sign. There's no equal, so I cannot include it in my answer. At 6, it was undefined, also don't include it. In infinity, we can't include that, and so it's all open brackets here. And as far as here, I could write or I could write my symbol, the U sign that means or, okay? And this is my solution. I'm going to box my answer. Let's get some more practice and look at number 3. All right, in number 3, I've already gone ahead and taken our first step of factoring. The only thing that we can factor is this term up here. Now, you'll find that in this case, the factoring won't be of much consequence. Would mainly save you some time when we are factoring in the denominator. That helps us find our least common denominator. But nevertheless, that was our first step, and I took it. So we find our common denominator, and here we are working with just numbers in the bottom. So remember, when we're working with numbers, in order to find the least common denominator, the thing we're looking for is the least common multiple. So what's the least common multiple between 8 and 10? Well, if you would go down their times tables and see where they first match up, that is 40. Our function is not going to be undefined because 40 does never equal 0. So here's one instance where you could find that no critical points come from undefined values. All right, good thing to know. So we're just going to move on and solve. But I don't think you need to see me go in and solve these equations since it's something that we've seen before. So what I've done is I've put down all my work. Go ahead and pause the video, do the work on your own and see if it matches up with mine. And then I'll comment on what we end up with. All right, go for it. So here's my solution. The way that I did this was I multiplied every term by our least common denominator, 40, and I isolated x. Now you'll notice that I chose to leave my inequality in here instead of making it an equation. Now the reason for this is we didn't have any critical points coming from undefined values, and this is a pretty straightforward equation that we can solve. Now by leaving that inequality in there, by the time that I get down here, I already know my answer. Now say you had left it as an equation. Now that would mean that you would have just one critical point. You would plot 5, and then in order to figure out whether less than was the solution or greater than 5 was the solution, you would plug in a test point. But since I just followed through in solving it, I know that it's when x is less than 5. Just a quick tip that might save you some time with problems similar to this. All right, let's look at our final example before I set you loose on your own. Okay, so I hope by this point you're feeling a little bit more comfortable about this. If not, go back and view the video for problems number 1 through 3. The way I'd like to treat number 4 is for you to try it on your own, and then I'll just reveal my work for it. That way you can do some error analysis and compare, and in case you got something different, go back and pinpoint exactly where you may have gone wrong. Okay, now I'll make this announcement now also about numbers 5 through 8. In order to get full credit for tomorrow's notes, I'll need to see your work for those. Please be really neat and box your answers so that when I come by, I can look at some of your answers and give you instant feedback on whether you're getting correct answers or not. All right, sound good? All right, here it goes. Here's the big reveal. Here's the answers for number 4. Go ahead and pause the video, and I'll see you all tomorrow.